So, I graded everyone who's turned in their homework. Not well pass out now because I have a lot of people who haven't turned it in. Close the door. Alright, let's go over some things. How many hours are you at school? So, why do I see 8 meters as an answer? So, over half of y'all completely just guessed on units. If the question asks how long or how many hours were you at school, you don't just guess a random unit. It should be hours. So, how fast should you drive on 1277? 55 what? Then why do I see 55 hours as an answer? So majority of people have received a lot of points off for just guessing and writing random units. If it's asking for how fast something is, that should be in either meters per second, feet per second, feet per minute, miles per hour. By the way, another thing. So I've seen some people put, for example, meters per minute as m divided by m. Meters is correct, but so m is for meters. Mi is for miles. And min is for minutes. Another thing, capitalization and lowercase are important. Lowercase a is for acceleration. Capital A is for amps or amperes. What you measure the current in your house. You measure the current flowing in your house in amps. Or your car battery produces so many amps of power. Capital A is for amps. Lowercase a is for acceleration. D versus capital D. This is for distance. This is for something else. Wherever letters I'm writing, it should be how you write it also. Another thing. KPS. I have no clue what that means. Doesn't mean anything. You want to do kilometers, should be km, not k. And if you want to do per seconds, you can put km divided by s. But they also wrote this, meaning for kilometers per hour. Kilometers per hour, you can either put it as h or km divided by hr. Meters per second, is written M over S. M/S. It is not MPS. MPS is nothing. The only thing we have this P is for miles per hour. Miles per hour can be written like that, or it can be written MI over H, or MI over HR. Let's go over. So one of the homework problems, were y'all good? One of the homework problems mentioned a 20 tall foot building, or 20 meter tall building. So when you're looking at the problem, what are they doing out there? Okay. It could be a drug test. Drug K9. So if your building is 20 meters tall, this number was not used in the problem. But some people went, well, I have to assign some number to velocity or speed, so they put your velocity is 20 meters. You're traveling at a rate of 20 meters. Makes no sense. Yeah, dropping a bowling ball. This 20 meters tall is called a red herring, is not used. For example, I think in one of y'all's future homework, there's a problem that goes like this. You are traveling in a pickup with a color of red number 5. And last year, I don't know how many people used the color 5, red number 5, as the initial velocity. You pass a sign saying 55 miles per hour. Again, it's the sign says 50 miles per hour. Tells you nothing about what the pickup's doing. I'm trying to think of it because I threw in as many numbers as I possibly could. You're traveling in a pickup with a color of red number 5. You're passing a sign saying 50 miles an hour. The truck is half a meter off the ground. Oh, yeah, that's a good one. The truck has 4 tires. The owner of the truck has $22 in his wallet. And traveled 5 miles past 5 o'clock diner. In 0.1 hours. So when you're doing these problems, do not just be randomly looking at numbers trying to figure out what they are. What they mean. You have to actually look at meaning. So the only thing out of this whole problem that's important is they traveled a distance of 5 miles in a time of 0.1 hours. So his speed would be 5 miles divided by 0.1 hours, which would be equal to 50 miles per hour. You have to actually read the problem to figure it out. Figure out what your variables are. So he's going 5 miles under the speed limit. You need to be asking yourself when doing these problems. So we need to be asking to see what his initial velocity is. So this is initial. Initial velocity is how fast you are moving at start. Technically it has a direction, so some people put that velocity and speed are the same thing. Velocity has a direction associated with it. So this is how fast you are moving at start, and there's a hidden in a direction. I usually leave the direction off in this class. In my real physics class, I usually give east, west, and directions, and they have to write that down every single time. For this, I usually treat speed and velocity as almost the same thing, but know that velocity has a direction associated with it. So you are moving toward the east, you are moving forward, you're moving backward. So usually positive numbers means forward. Negative numbers mean backwards. That's how we give direction in this class. So a statement that says a car is at rest. ... This statement means that the car is not moving. Its initial velocity is 0, and meters per second or miles per hour. So when identifying your initial velocity or speed, you need to ask yourself how fast they are moving. Don't be looking for a random number or don't record the first number you see. I don't know how many times I've seen people look at a random number and just give it to BI. Your speed or velocity is going to have some distance unit, so that could be meters or it could be miles, and some time unit. So speed, the units for this is equal to distance over time. So for example, miles over hours. So this could be 0 mi over h. So if it just has mi over h, some distance unit over some time unit, your time units are seconds, minutes, hours, months, days, years. If it has a distance, that's going to be a velocity or speed. You then need to ask yourself, what is it moving at the end? So final velocity is the speed at the end. What you ended up at. So if it said a car came to a stop, a car came to a stop. That means that at the very end, their final speed was 0 miles per hour. Acceleration is, so acceleration, again we use lowercase a, is how much speed is changing by. So for example, if you're gaining 5 miles per hour every second, that means that you are gaining 5 miles per hour, so your acceleration would be 5 miles per hour per second. This is talking about how much your speed is changing. Or if I said that you're moving at a rate of 5 meters per second squared. 5 meters per second squared means that you are moving 5 meters per, you're gaining, so you are gaining 5 meters per second every second. There's a hidden additional second here. The second squared means that there's another second in there. There are 2 seconds, one here, one here. This means that every second, you get 5 meters per second faster. So every second, you are traveling 5 meters per second faster. Does that make sense? So a lot of people then just randomly plug numbers into random equations. I should also say before continuing that final velocity minus initial velocity is change in velocity. How much your speed increased by. Compared to your starting speed. So VF minus VI is your change in velocity. How much your speed increased by compared to your starting speed. So if I asked you to find final speed, final would just be equal to your initial plus your change, VF minus VI. So it'd be equal to initial velocity plus change in velocity. in doing the triangle, we have acceleration, Vf minus Vi divided by t. If I were to ask you to solve for change, you'd circle it. And people then just randomly put A divided by T. So it should be by the way, the code word of the day is apples. This is for remote learners. The code word of the day is apples. To ensure that they're watching the videos. So Vf minus Vi would be equal to A times T. So we circle wherever we want to find. And then we look at the remaining of the triangle. Notice that they're next to each other, so we use multiplication. If I asked you to solve for acceleration, you would circle it. Or if I told you to solve for time, so time would be equal to Vf minus Vi over A. So this one is over this one. So it would be this one over that one. So once you got this equation, and by the way, I know that it takes a lot of time writing this triangle, writing the equation. It helps. Everyone that did this usually got a better grade than the people who just worked out and didn't draw the triangle. The only thing that really hurt people was putting random units. Like it took 20 meters to complete a task. Yeah. If you want to know your grade, I'll tell it to you. But I'm gonna pass it back out later, probably tomorrow or the next day. Does anyone have homework that didn't turn it in? By the way, did y'all all figure it out? Y'all had different numbers? Everyone had different homeworks? Yeah, everyone had different homework, which is why I can know who copied off of who. If you had answers on your paper that matched someone else's, I know one, you just sat there and copied it off of someone else. I know who you copied off, so I know who shared. So, yeah, so if you actually have wrong, but basically, yeah, everyone had different answer or different numbers. Last year, the class figured it out in 2 seconds. I passed 3 homeworks out, and the first 2 students immediately turned around and looked and was like, "Hey, you have a different number than me." So let's see. You increase your speed from 5 meters per second to 10 meters per second. And was accelerating at 2.5 meters per second squared. How much time did you spend accelerating? First, how much time? So you were looking for time. We know our answers are going to be either in seconds, minutes, hours. Your final answer is going to be in seconds, minutes, hours. To figure out your time unit, we look at acceleration. So acceleration has a second squared. So our acceleration, we are gaining 2.5 meters per second every second. So that's 2.5 meters per second every second. Meters per second squared is the same thing as meters per second. So this is going to be our time unit. Our answer is going to be in seconds. So to figure out what unit is, we look at our acceleration. We're going from this, so that'd be your initial, and we're going to this, so that'll be your final. A meter per second is telling you how much meters you travel every second. That's the rate at which you're moving. So these would be speeds or velocities. Again, it's important that you draw your triangle and actually show your work and do it. So we're solving for time. So time would be this over that. Note, another thing people did is they did this correctly, and then they just came over here and just put random numbers in. This VF corresponds to this VF. So in this spot, I'm going to write 10 meters per second. You don't have to write units when showing your work, but VF, you need to plug it into the VF spot. Then you do VI. VI was 5 meters per second, and this should be A. And then our acceleration was 2.5 meters per second. Hello? Alright. Elena, you can pack up. You're about to be picked up. You can't leave yet until they come get you. But you're being picked up. So meters per second is your acceleration. So what this acceleration means is you're starting at 5 meters per second, and you are going to reach 10 meters per second. So somehow you're going to reach 10 meters per second. You are gaining 2.5 meters per second every second. So you're going to add 2.5, and that gives you to 7.5 meters per second. Then you're going to add another 2.5 meters per second, and that's going to get you to 10. So you do this for 2 seconds. You can open the door. You can take your stuff to your leaving. So it took you 2 seconds. You can also, when writing this out, put parentheses around this in the calculator. If you can't plug it into the calculator, just do 10 minus 5 first. 10 minus 5 is 5. And then plug this into the calculator. I don't know how many people wrote this right, but just got a wrong number at the very end. So this would be equal to 2 seconds. Again, we use the value in the acceleration to figure out time. Does this make sense? So let's do another. You are traveling at 100 miles per hour and slam on the brakes. You begin slowing down at negative 10 miles per hour per second. So this is your acceleration. You're losing 10 miles per hour every second. What is your speed? What is your final velocity after 7 seconds? So we know that we're initially, so you write down you're initially going 100 miles per hour. We know that our acceleration, we're changing by 10 miles per hour every second. And it's asking what about our final speed after 7 seconds. So we're looking for final speed. First thing, we need to see how much our speed has changed by. So let's figure out how our speed has changed. So our change in speed be equal to your acceleration times time. Our acceleration is negative 10 miles per hour per second for 7 seconds. So again, this means losing 10 miles per hour every second. So after 7 seconds, we lost hour. To figure out our final speed, we start with what we began with. We start with our initial speed, and then we add our change in speed. We started at 100 miles per hour, and we lost, the negative means lost, 7 miles per hour. So after 7 seconds, our new speed is 30 miles per hour. So if you are traveling at 100 miles per hour and slam on the brakes, and if your acceleration was negative 10 miles per hour per second, your final speed would be 30 miles per hour. Again, you identify your variables by reading the problem. You are traveling at 100 miles an hour, so that's your initial. You begin slowing down. So slowing down means you're accelerating. So this would be your change in speed. And we're looking for final velocity. Also, I would suggest this also. After you did all the math, look at your answer. First of all, also, box your answer. On your homework, it should be boxed and on the right side. But let's think about, does this make sense? So if you start at 100 and you lose 10 every second for 7 seconds, that means you start at 100 and you're going to lose 10. So 90, 80, 70, 60, 50, 40, 30. 7 seconds. Your answer should be around 30. I told you some problems you can't do it, but you shouldn't solve it. But I didn't solve it. This is just a check your answer by thinking it through. So if we think about this, we're what I would have done. So let's say this was too long. So I would have thought, well, we're doing 100. I'm losing 10, so I go 90, 80, and I'm doing it for about 70. I would think the answer, if I continued this down, would be somewhere around 20 to 40, right? Now, some people who did this got a wrong answer and put that you would be going 1,000 miles an hour. They did this by multiplying like our 7,000 miles an hour. They did this by multiplying these numbers together. If you're going 100 miles an hour and you're losing 10 miles an hour every second for 7 seconds, I would expect the final answer to be somewhere low. You need to be thinking, does your answer make sense? The number one thing that I've been seeing is this. Someone wrote 41 divided by 55. So 41 divided by 55 and got an answer of 1.34. Do y'all know what 41 divided by 55 is? Without using a calculator? Why can't it be 1? This number is smaller than this number. It should be between 0 and 1. What they put into the calculator was 55 divided by 41. They put it in backwards into the calculator. So stop and look at your answer and ask, does it make sense? 41 divided by 51 should be a fraction, something less than 1. Yes. I think I know what the lockdown was about now. Probably a medical emergency. Yeah, when she gets back. So are any questions? I already gave the code word, didn't I? Yeah.